We are in downtown Washington, D.C., and this is the central heating plant. Steam generated in this facility is piped underground to the government buildings located in this complex. Zern boilers number 5 and number 6 are direct fired with pulverized coal. And here we see the 4 Williams DF pulverizers in operation. Each set of pulverizers feeds one boiler, as will be shown later. This is an overview schematic of the Zern Williams direct-fired coal pulverizer system, with the pulverizers located in the basement, the burners located just above the control room floor, and the upper furnace section complete with superheater and convection section. Each Williams DF52 pulverizer is equipped with its own microcomputer control panel. Both manual mode, as shown here, and automatic mode is possible. During automatic mode, the boiler demand, in the form of a 4 to 20 milliamp signal, is transmitted to the computer, which in turn increases or decreases the pulverizer's speed, thereby modifying the coal production rate. Simultaneous to this, the air system is balanced so as to maintain constant air-to-coal ratio, and the active classifier, shown here, is controlled so as to achieve constant coal product size from maximum coal rate through minimum turndown. The Williams patented DF pulverizer is manufactured in capacities ranging from 1 to 23 tons per hour of coal. The mill's drive skid assembly, shown here, is skid mounted for ease of removal and ease of access. Any component can be removed without disassembling the pulverizer. The pulverizer cross-section, shown here, has a large access door through which journal assemblies are easily removed for yearly maintenance. Removal of all journals takes less than 4 hours. This is the spinner separator, which is an active classifier and controls the coal's fineness over the entire load range. This is the main control panel for the Zern boiler number 5. This system is designed to produce 220,000 pounds per hour of steam, or 240,000 pounds per hour on a continuous peak basis. The steam pressure is 250 psi gauge and is saturated. Since the facility is located adjacent to the U.S. Mint, the Zern design also incorporated the possibility of burning shredded paper money. However, at this time, the main fuel source remains number 6 fuel oil and or coal as fed by the Williams pocket feeder. The feeder is driven by means of a 5 horsepower variable speed clutch and gear reducer, allowing infinite speed changes under direction of the microcomputer shown earlier. With an inspection port removed, it is possible to see the coal as it is valved into the pulverizing system. This is Virginia bituminous coal with a heating value of 13,500 BTUs per pound. After delivery by railroad car to this plant site, it is pre-crushed to this -2 inch and bunkered overhead. The coal then drops by gravity into this volumetric pocket feeder, which valves the coal into the system. The sound you hear is the coal dropping into the pipe. The pulverizer makes little to no sound. Shown here is the drive skid with the main drive motor, variable speed clutch, and right angle gearbox and coupling. For purposes of demonstration for this picture, the pulverizer access door has been opened and the Williams pulverizer operated in a slow speed mode. Note, faster operation would be hazardous. The grinding operation is as follows. Coal falling into the grinding zone is lifted both by plows located ahead of each grinding roll and fluidizing air entering tangentially around the pulverizer. Pulverization takes place between the Nyhard grinding roll and the forged bull ring. Grinding roll assemblies are free to pivot and have no springs as compared to competitive bowl mills. Capacity adjustment is achieved from 100% to 0% output by varying the central rotational speed. Since centrifugal force varies as the square of the rotational speed, so production will increase or decrease accordingly. Automatic lubrication of the journals and all other bearings is accomplished through the use of a Trabon automatic lubrication system connected to divider valves which meter lubrication under pressure to each journal. An air-operated barrel pump causes lubricant to be moved under pressure to each metering valve. Pressure failure alarm or broken line indication automatically alerts the system operator so that he can plan a shutdown. Each Williams DF pulverizer is equipped with a tramp metal throwout. By opening this large gate, removal of tramp metal and hard-to-grind materials is accomplished. This is normally done periodically. Hard-to-grind particles such as iron pyrites, slate, and gravel will accumulate at the bottom of the fluid bed and can be dropped out of the system as needed. It is possible to beneficiate marginal coals by continuously removing hard-to-grind materials such as pyrites. Tramp metal will sink to the bottom of the fluid bed for periodic removal. In addition, should a furnace trip occur, the mill can be unloaded if desired by jogging with the tramp metal chute opened. The DF mill is driven by an external gearbox, thereby eliminating contamination problems. Leakage from inside the mill is not possible. Thus, Williams has the most advanced direct-fired coal pulverization system in the field today. In addition, Williams uses an active classifier we call a spinner separator, shown as the variable speed drive system. Because of the active classifier design, sieve analysis of the pulverized coal remains constant at high or low loads. At 70% minus 200 mesh, there is zero 50 mesh oversize. Pulverized coal and air rise into the separator, where spinning blades force the heavier particles back down for regrinding at the mill zone. Air bustles or wind boxes surround the DF mill, conveying hot gases into the grinding chamber. These gases simultaneously dry the surface moisture from the coal and convey at the same time, resulting in a turbulent fluid bed that promotes rapid drying of the wet coal. The properly sized coal exits the spinner separator from the top and in a negative system such as this is sucked into the primary air fan inlet. Here we see the fan driven from the same motor as the pulverizer via a jackshaft and V-belt drive. A separate fan drive is of course optional. A temperature sensor located in the ductwork ahead of the fan senses the system temperature, which is normally maintained at or about 180 degrees Fahrenheit. This sensor connects to a transmitter that feeds back to a temperature controller. The controller pneumatically adjusts a lever-equipped operator, which in turn opens and closes cold air barometric dampers. Hot gases drawn into the negative pressure system from the furnace air preheater is thus tempered and controlled to do the drying job without overheating the coal. The coal's normal exit temperature is 150 degrees Fahrenheit. And it is air conveyed down this pipe and into the primary air fan. From the fan, the coal air mixture travels upwards to the burners. Since this furnace is equipped with 2 burners for each pulverizer, the coal-air mixed first traverses a set of splitter valves. Each leg of the valve is adjustable, and thus an equal coal-air load can be regulated to both burners that are located several stories above the pulverizer floor. All coal piping consists of easily replaceable standard seal piping with standard elbows joined by quick fit couplings. We are now at the main control center level, and here we can see the coal pipes as they emerge through the floor and continue on up to the burner level. At this time, the coal-to-air ratio is 2.7 pounds of air per pound of coal, and the coal has been dried from 8 to 10% moisture down to less than 1%. Zurn design, engineers, and constructs burners to complement each steam generating system. The Zurn pulverized coal burner shown here is also equipped with an oil gun assembly for burning number 6 fuel oil. This is a cross-section of the Zurn burner. Pulverized coal enters through a coal inlet pipe shown at the bottom left. Number 6 oil enters through the oil gun assembly, center left, and both fuels flow down the barrel and are dispersed by a diffuser into the secondary airstream. Dual air registers can be used to optimize secondary air distribution. By opening a port in the side of the furnace, we can now take a look at the burner from the side as it burns coal. The main purpose of the Washington, D.C. Central Heating Plant is to supply steam to all the major government buildings, such as the Bureau of Printing and Engraving, as shown here, the Department of Agriculture, shown to the right, the Washington Monument, shown in the background, the White House, and all other important government buildings. The Zurn-Williams pulverized coal-fired system utilized to heat these buildings is designed to meet air pollution control standards. This system starts with the Williams pulverizer integrated into a compatible air handling system complete with Zurn burners, boilers, and necessary air pollution control components, culminating in a total systems approach that is both reliable and cost-effective.